Hello there, Mr. Sutton here, bringing you the Algebra 2 10-7 Part 3 homework solutions on using trigonometric identities. In this one, we're focusing on verifying trig identities. To verify this identity, we're going to focus exclusively on simplifying this left side to see if we can turn all this into sine of x. So first thing I'm going to do, just going through my simplifying sort of steps, I notice we have an angle identity with this cofunction that we can work with. I can turn this into cosine of x using my cofunction identity. So we've got cosine of x for that. And this tangent, I can also start working on that. I can turn this into sine over cosine because there's nothing else left to do other than sine and cosine at this point. So then we have these cosines canceling out, leaving us with sine of x, and that proves the identity because that's what was on the other side there. For this identity, we're going to try to turn this left side into cosine squared of x. So taking a look at this left side, there's a couple things I can do. In the numerator, I can turn secant into 1 over cosine, so that'll be pretty useful up there. In the denominator, I notice that I've got a squared trig function, so I can use one of my identities. We have the 1 plus tan squared equals secant squared identity. So this whole expression down here can be replaced with secant squared. All right, so my numerator, I can cancel out these cosine of x's. So that's just 1 up there, and we still have that secant squared in the denominator. Well, 1 over secant squared is really, if we use our reciprocal identity, just the same as cosine squared of x, and that matches what we were supposed to prove in the beginning. On this problem, we're trying to show that this left side and this right side are the same thing. So let me work on simplifying the left side. In the numerator, I have a cofunction identity. I can convert this into sine of just theta plus 1. And in the denominator, I have a negative angle identity. Sine of negative x is going to be negative sine of the angle. So this actually is 1 minus negative sine of theta, or 1 plus sine of theta. Now what I notice right away here is these are actually the same factor, so those can cancel. And that's just going to leave me with 1, which is what I was trying to show in the beginning. For this problem, I'm trying to prove this identity. So there's a couple ways to go about this, but I think I'm going to work with the left side here, just simplify that a little bit to see if I can get it to look like this other expression on the right side. So on the left side, I have a cofunction identity. I think taking care of that is pretty crucial. Tan of a complement is the same as cotan of the original angle, so cotan of x. So that means we have cotan times cotan, which is cotan squared. Now that doesn't quite match what we have over there. However, we have an identity. 1 plus cotan squared equals cosecant squared. So if I wanted to replace cotan squared with something, with this identity, I could subtract 1 over to the other side, and then I would see that cotan squared was the same as cosecant squared minus 1. Well, if I make that substitution, I notice that I actually have what they were asking me to match in the beginning, so I'm done. For this next problem, we're trying to show that the stuff on the left here and the stuff on the right are the same thing. This one's going to take a little bit of work. So I'm going to start with the left and see how much I can simplify that. Now, one thing I notice, I don't have any special angle things or squared trig functions, so really it's down to algebra. I can't even do the sine cosine dance because we've already got all sine and cosine. So algebraically, what can we do? Well, I notice that there are 2 terms on the left side and there's 1 term on the right side. So if I can at least turn this into a single term, that might be a step in the right direction. To merge fractions together by addition, I have to find a common denominator and get everything to have that denominator. So looking for my LCD, just kind of thinking back to that mode of thinking, I notice that I have a sine of x and a 1 plus cosine of x in my denominator. Those are 2 totally different factors, so those are both going to be part of any LCD that I'm constructing to move these together. So in order to get these to get moved together, I have to multiply each fraction by what it's missing from the LCD. So my first fraction, 1 plus cosine of x over sine of x, I have to multiply that by 1 plus cosine of x because it's already got the sine already in the denominator. So this first thing is going to get multiplied by 1 plus cosine over 1 plus cosine. This second fraction is missing the sine of x in the denominator, so we'll multiply by sine over sine for that one. And at this point, we've got a little bit of multiplying to do. Let's do the easy part first. The denominator is just going to be sine of x times 1 plus cosine of x. And I'm actually going to move everything into one big fraction right away, so that is my common denominator that I can keep. Now in my numerator, this first fraction that I used to have here, just multiplying these together, this is an a plus b times a plus b situation. So we can do a squared plus 2ab plus b squared as kind of a shortcut for this, or you can FOIL this whole thing out, that's fine. So we've got the first thing squared is going to be 1. Multiplying the first and second thing together and doubling that is going to give us a 2 cosine of x that we're adding in there. And squaring the last thing gives us cosine squared. Now over here, sine times sine is sine squared. What can I do at this point? Well, I notice I have some squared trig functions, and I have an identity of sine squared plus cosine squared equals 1. Well, I've actually got sine squared plus cosine squared right here. So this piece of the numerator, anyway, can be replaced by just the number 1. And that makes things a little bit nicer, because now I can add these 1's together. That's 2. And what else can I do? Well, I can factor the numerator a bit. So if I take a 2 out of these, I have a 2 parentheses 1 plus cosine of x. Now that's very helpful because I have a 1 plus cosine of x that I've had for a while in the denominator. I can cancel those now, and that leaves me with just 2 over sine of x. And I can use the reciprocal of sine, cosecant, to move this into the numerator here. So I can rewrite this then as just 2 cosecant of x, which is what I was trying to show at the very beginning. For this problem, we're trying to verify this trigonometric identity. Now, this is one of those problems where it might actually be easier if you work with each side simultaneously to get them to match up. But here's how you could do this working exclusively with the left side and just kind of massaging that to look like the right side. So first thing I notice on the left side, I've got this negative angle. Cosine of negative x is the same as cosine of positive x. That's one of my negative angle identities. So I can actually rewrite this as 1 minus just cosine of x. And where can I go from this point? Well, there isn't really much else I can do, except this is one of those situations where I can use trig conjugates to change the form. It won't necessarily make us have a simpler answer than this, but it will change it. So I can multiply this by 1 plus cosine over 1 plus cosine. That's going to give me sine of x times all this stuff in the numerator, and in the denominator I'll have 1 minus cosine squared of x. Now the reason that I can move forward by doing that is because now I have a squared trig function, so I can use my sine squared plus cosine squared equals 1 identity. If I subtract cosine squared to the other side, 1 minus cosine squared is the same as sine squared, so I can swap this out now for sine squared. And that allows me to cancel out the sine of x that's in the numerator, giving me 1 plus cosine of x over sine of x. Now this doesn't seem to be all that different from what we started with back up here, but there is a subtle difference. Since I have a single term in the denominator now instead of the numerator, what I can do in this situation is I'm actually allowed to split this fraction up and divide both things in the numerator by sine of x. So I can write this as 1 over sine of x plus cosine over sine of x. Now normally that wouldn't really be great because now we have 2 fractions instead of 1. Only these 2 fractions can be simplified a bit. 1 over sine of x is just cosecant of x. Cosine over sine is cotan of x. And that isn't really any simpler than what we started with, except that it matches what we were trying to match. And that was really the name of the game on this one. For this problem, we're told that a generator of a laser beam has a height of h, and the length of the laser beam shown here, measured from the generator to the target, when the angle from the surface to the generator is theta, can be modeled by this equation. Okay, we'll take their word for it. We want to show that this equation is equivalent to just having s equals h times cosecant of theta, which seems like a much friendlier formula than whatever they came up with here. So we're basically trying to show an identity. So let's go ahead and see if we can turn this into h cosecant of theta. A couple things I noticed right off the bat. Cotan in my numerator, I could change that into cosine over sine of theta. And in the denominator, I have this weird complementary angle cofunction thing. I can turn this into cosine of just theta. So at this point, to make this fraction less complex, I'm going to multiply by the reciprocal of this cosine here. So multiplying the numerator by 1 over cosine, that gives me h cosine of theta over cosine sine of theta. Once I've set it up like this, these cosines can cancel out. So now I just have h over sine of theta. And 1 over sine is really just cosecant, so I can turn this into h cosecant of theta, which is what I was trying to show from the beginning.